Around 1900, there were two great pillars of physics: Newton's law of gravity and Maxwell's equations for light. However, the problem was that the two conflicted with each other. Thus, Einstein unified these theories together by creating the theory of relativity. Today, once again, we have two great pillars of physics: Einstein's theory of relativity and quantum theory. And of course, these two conflict with each other. There must be a great theory that unifies these two into one pillar, and that may be the string theory. Buckle up, because today we're taking a trip to the mind-blowing world of string theory. Now, what exactly is string theory? Well, the string theory is a theory which states that the universe is not formed of point particles, but instead of tiny vibrating strings. And each note of vibration of the strings correspond to subatomic particles. Therefore, they say that everything in the universe can be reduced to the notes of strings. Why, you ask? First of all, physics' goal is to unify everything in the universe and come up with a theory that governs the universe, or the theory of everything. And there are four fundamental forces in the universe: electromagnetism, the strong nuclear force, the weak nuclear force, and gravity. If physicists succeed to unify these four forces, it would be the theory of everything, or at least something close to it. Now at this point, three of the four forces are successfully unified by what is called the Standard Model, and those three forces are electromagnetism, the strong nuclear force, and the weak nuclear force. This indicates that there is only one force left to unify: gravity. To make this possible, first, physicists created the graviton, a point particle that, as it moves towards the speed of light, it is surrounded by waves of gravity which obey Einstein's equations. The problem occurs when the physicists make graviton bump into other gravitons, as well as atoms. The resulting collision creates infinite answers. And for those who don't know, infinity just indicates that there is some error in the physicists' calculations. Even if they attempted to imply the ways they used to formulate the Standard Model, they all failed. Physicists needed something new and entirely original. And string theory may be just that. So in a nutshell, the Standard Model successfully unified the three out of four forces in the universe, and the string theory is what attempts to unify the last force: gravity. As the string theory evolved, it began to be revealed that the theories somehow cannot exist in our dimension, or any other dimension, except for 10 dimensions. Usually, theories can be applied to any dimensions, and thus this result truly shocked physicists. To many of them, this was just proof that the theory was incorrect. However, physicists couldn't ignore the fact that all other rival theories were suffering from fatal flaws, such as infinities. So they reckoned that perhaps string theory is correct. Perhaps all 6 other dimensions are curled up, and our atoms are too large to enter it, and that's why we can only exist in 4 dimensions. Despite all the craziness of the theory, there is one feature that has kept the theory alive: the marriage of general relativity and quantum mechanics. And for those who don't know, here's a quick explanation of the two theories. General relativity is a theory that describes gravity and things on a very large scale, such as galaxies and black holes. Quantum mechanics, on the other hand, is a theory that describes the very small world. And the thing is, these two theories have completely different rules. Going back to the story about string theory, As I previously mentioned, whenever physicists in the past collided a graviton without the gravitons and matter, all they got were a bunch of infinities. However, the string theory can magically remove these infinities. And this magic occurs through something called supersymmetry. Everything in the world can be separated into two categories, bosons and fermions. Basically, bosons are particles that create all forces in the universe, and fermions are what make up all matter in the universe. And supersymmetry finds duality in these two types of particles, making it so that every particle in the universe can be rearranged with each other. This indicates that every particle has something called a superpartner. For example, electrons have selectrons as their superpartner, quarks have squarks, and leptons, which are electrons and neutrinos, have sleptons. I know they sound a bit odd, but this is real physics. And here's the trick. In string theory, there are two quantum corrections. Quantum corrections from fermions and corrections from bosons, in which these two are equal in size but have the opposite signs. And because of this, as you may have realized when you heard the sentence equal in size but have opposite signs, when these corrections are added together, they cancel out, leaving a finite result. And this is why this theory successfully unifies the theory of gravity and the quantum theory. In conclusion, string theory stands as a beacon of hope in the quest for a theory of everything, a unifying melody that could harmonize the seemingly discordant notes of our universe. Leave me your thoughts on the comment below. Now let us return to our everyday life.